All right, class. In this video, we are going to be looking at populations and the normal curve. So, um, so let's say, now these numbers are going to be all fake, I'm just making them up, but let's say we've got some population, and the people in this population, right, if I look at all the different individuals that are hiding inside this population, let's say that we surveyed somehow every single adult in the United States and ask them, hey, how many donuts are you eating per week? And let's say we got all kinds of different answers. Some ate 2, some ate 10, some ate 50, not per week, per month. And so let's say that the average number of donuts that the adult eats per month is 28 in the United States. 28 donuts per month. Donuts per month. And then let's pretend that the standard deviation is I don't know, 5 donuts per month. Okay. All right. So first thing we want to do is we want to say, okay, well, what does this mean? And then let's also say that we collected all this data and we plotted it and we say, okay, well, the distribution looks something like this. And so let's say that the distribution ended up being normal. Okay. So we have our mean here. So this is going to be 28 donuts per month here. I'll just write 28. Okay, 28 donuts per month here. And I know that one standard deviation away is going to be, so I'm going to add, so that's going to be 33 because I add 5 to 28. So it's 33 donuts per month at one standard deviation. And over here at 2 standard deviations, you have folks that are eating 38 donuts per month. And then on the other side, right, I could go to minus 1 standard deviation. So this would be 23 donuts per month. And I could go over here to minus 2, and this would be, this would be 18 donuts per month, right? And so I'm just subtracting 5 to get to here and subtract 5 again to get to there, right? So, okay, so now we're looking at this and saying, okay, here's the spread of our distribution. And here are some values of standard deviations. Now, one thing that we could do if we wanted to is if we wanted to think about this in terms of the empirical rule, we could say, okay, hey, look, this is normal, so I can use the empirical rule. So between minus 1 and 1 standard deviation, right, if I'm looking at all of the individuals, how many folks are in between minus 1 and 1 standard deviation? Well, the empirical rule tells me that that's 68% of all my population lives in between minus 1 and 1 standard deviations. Okay, and if I wanted to step out even further and go out to 2 standard deviations, right, that's going to be 95% of my population lives between minus 2 and 2 standard deviations. And I mean, that's almost everybody, right? 95%, almost all of, as long as you're dealing with normal data, almost all of your population lives in between minus 2 and plus 2 standard deviations. And that's pretty cool. And another thing to think about, right? If this whole block is 95% of the population, well, how much does that leave left for out here in the tails, right? How much of the population am I ignoring? Well, if this is 95, then that leaves 5% that I have to split up between 2 tails. So this would be 2.5% in this tail, and this would be 2.5% in this tail over here. 2.5. Anyways, so I mean that's a little bit of how the empirical rule works. So the empirical rule is really useful if you're dealing with whole standard deviations, but a lot of the times we're not. So what do we do in those cases where I don't have whole standard deviations to play around with? Well, that's what this video is all about, is what do you do in those cases where you don't have whole standard deviations, right? So let's say that I wanted to know, well, how much of the population then is eating between 15 and 30 donuts? Okay, so I'm going to come out here. So here's 15. And okay, well, here's 30. Okay, so what's this, right? How much of the population is this? How many U.S. adults eat between 15 and 30 donuts? Well, so this is where I'm going to use some of the tricks that the normal curve allows me to do. So I come down here, and what I need to know is, well, what is the z-score here? And what is the z-score here? Well, I know that this z-score is going to be less than 1, and I know that this z-score, right, this is minus 2, so it's going to have a value that's a little bit bigger than minus 2. But to calculate it exactly, right, z equals x minus the mean divided by the standard deviation, or if we were dealing with a sample, it'd be x minus x bar over s. I mean, it's essentially the same thing, but since we don't have a sample and we're dealing with actual population values, we're going to use this one. So let's calculate these. So this first one, this is going to be 30 minus 28 divided by 5. And over here, this is going to be 15 minus 28 divided by 5. Okay, get our trusty calculator out and run these numbers really fast. 5 is sticky. Divided by 5. So this has a z-score of negative 2.6, and that's what I expected. And this one, divided by 5, this has a z-score of 0.4, and that's what I expected as well, right? Less than 1. So these are the two z-scores that I'm interested in, okay? So now what do I do? Well, if you've watched any of the other videos, you know that I'm going to hop out to my z-table, okay, right? Because my z-table says, right, if here's a normal, if this is a normal distribution, and I know my z-score is here, well, the z-table will tell me how much of the population is to the left of that. So let's start with this one, okay? How much of my population is to the left of 0.4? And it shouldn't be very much. So let's go over here and see. So I'm interested in 0.4. And again, the way the z-table works is it's going to tell me everything that's to yeah, it's going to tell me, oh, and that's this one. Oh, that's a lot of the population, right? This is going to be a huge amount, right? This is a lot, big thing. Anyways, so how much of my population is to the left of 0.4? Like if this z is 0.4, then where is the stuff? So I'm going to come down here, starting z. So it's not this one, it's not this one, not this one, not this one. Okay, here's 0.4. And now I come over here. Well, what's the next number? So 0.40 is this one right here. So this tells me that 0.6554, that the proportion of the population that is to the left of a z-score of 0.4 is 0.6554. So let's copy that down over here. So this is 0.6554. That's that proportion. Or what it's saying is that for folks that eat 30 donuts, there's 65%, well, 65.54% of the population eat fewer donuts than they do. Okay? So now let's find this one. Okay, negative 2.6. So I'm going to go to my other table that has the negative values on it. I want negative 2.6. So that's right here. Negative 2.60. So that's going to be the first one. That's this value, 0.0047. Okay, so let's take that back. 0.0047. And so now I know this blue area right here is, or the proportion is 0.6554. And I know that, let's say that this is green, that the green proportion is 0.0047, and that would be this right here. So to find the stuff in between, what I'm interested in, this value, that proportion, I'm just going to subtract the two. I'm going to take 0.6554, and I'm going to take away from it this little one, 0.0047, and I'm going to get, so for this, the difference between those two proportions is 0.6507, or what this is telling me is that for adults that eat between 15 Okay, so the percentage of people that eat between 15 and 30 donuts per month, 65%, well, 65.07% to be more exact, eat between 15 and 30 donuts per month, given um, given this all this data that I've calculated and I'm looking at here. So that's a lot of people eating a lot of donuts. Good thing these are made up numbers. So let me see here. One other thing that they could ask is, let me erase this, give myself some space to work, is they could say, all right, well, how many people then eat fewer than, so they could say, all right, well, I want to know how many people are eating fewer than 10 donuts per month. What percent of the population eats fewer than 10? So 10 or fewer donuts, right? How many people are doing that? What is the proportion? So let's look. So I'm going to do the exact same thing, right? If I have my distribution, I need to know, right? So this is 28, so 10 is going to be over here somewhere. I need to know, right, what is this area? And to find that out, exact same pattern. I'm going to say, okay, I need the z-score. So I'm going to go 10 minus 28 divided by the standard deviation, which is 5. It's going to give me a negative value, which I know that I need. 10 minus 28 divided by 5. So this is negative 3.6. And I know that I need this to be negative because I'm to the left over here. I'm to the left of the mean, so I know I have to have a negative z-score. And then I'm going to go to my negative table. So where's negative? Oh, look, it's right here. This one, negative 3.60. So that's going to be this first value, 0.0002. Almost no one. 0.0002 is the proportion. In a percentage form, this would be, right, move the decimal place twice, 0.02%. So way less than 1% of all people eat fewer than 10 donuts per month in the United States. If this was, and my son Marcus just got home from school, if this was a correct, if this data here was correct. Luckily, I just made it up. Hopefully, we don't have this big of a donut problem in the United States. But that's how this works, and that's how you deal with populations and the normal curve. Let me know if you have any questions. Thanks.